The final years of the Second World War witnessed desperate efforts to overcome piston engine limitations. Jet-assisted takeoff systems and rocket boosters provided performance increases for conventional aircraft, bridging the gap between piston-powered and pure jet propulsion. German rocket-assisted fighters. The Messerschmitt Mech 163 Komet became the only rocket-powered interceptor to achieve operational status. This tailless aircraft featured a Walter rocket motor, burning volatile chemical propellants. The Komet achieved speeds exceeding 600 miles per hour, making it the fastest aircraft of the war. Its revolutionary design eliminated traditional empennage, relying on swept wings for stability. German forces deployed Mech 163s, defending industrial targets against Allied bomber formations. The aircraft climbed rapidly to intercept altitude before making high-speed attack passes. The Messerschmitt Mech 262 occasionally employed rocket-assisted takeoff systems. This twin-jet fighter normally operated on turbojet power alone. Short runways or heavy loads sometimes required additional thrust during takeoff. Jettisoned rocket bottles provided brief additional acceleration. The system allowed operations from damaged airfields or with external stores. German forces employed this modification when circumstances demanded. The rocket assistance proved purely supplementary to primary jet propulsion. Mech 262 operations primarily relied on turbojet power, with rockets providing emergency capability. The Heinkel HE-162 Salamander never received operational rocket assistance, though systems were proposed. This lightweight jet fighter featured a single turbojet mounted above the fuselage. Development occurred during Germany's final months when resources and time were scarce. Proposals for rocket-assisted takeoff existed but were never implemented. The HE-162 entered limited service during war's final weeks, operating on jet power alone. Rocket assistance remained a theoretical enhancement, never realized operationally. The aircraft's brief service prevented development of auxiliary systems.
Japanese rocket-powered interceptors. The Mitsubishi J-8M Shusui represented Japan's attempt copying the German Me-163 Komet. This rocket-powered interceptor featured similar design and propulsion concepts. Japanese engineers worked from German technical data and a single imported Me-163. Development proceeded slowly due to Japan's limited industrial capacity and resources. The Walter rocket motor proved difficult to reproduce with available materials. Only 2 prototypes were completed before war's end. Neither achieved operational status or combat missions. Test flights revealed serious problems with the rocket motor and fuel system. The volatile propellants proved as dangerous in Japanese hands as German experience had shown. One prototype crashed during testing, killing the pilot. Japan's defeat arrived before development could progress further. The J-8M demonstrated Japan's technological ambitions but highlighted industrial limitations. German rocket technology proved too advanced for Japanese industry to replicate effectively. The program represented wasted resources during Japan's desperate final year. The Yokosuka MXY-7 Ohka represented a different rocket-powered concept. This piloted flying bomb was carried beneath Betty bombers before release. The pilot ignited solid-fuel rockets for the final attack dive toward Allied ships. The Ohka achieved high speed during its terminal dive, making interception difficult. American forces called it Baka, Japanese for fool, reflecting the suicide mission. Japanese naval aviation deployed Ohkas during Okinawa campaign operations. Most were shot down before reaching targets as American fighters destroyed carrier bombers. Operational effectiveness proved limited despite the weapon's theoretical capability. The Betty bombers carrying Ohkas became priority targets, easily identified by their unusual configuration. American combat air patrols shot down carrier aircraft before they reached launch positions. Few Ohkas actually struck targets despite numerous missions. The weapon represented Japan's desperation, sacrificing pilots in weapons that rarely reached their targets. The rocket propulsion provided high terminal velocity but couldn't overcome fundamental tactical vulnerabilities. Production exceeded 800 units, though most never flew operationally. German jet-assisted takeoff systems. The Messerschmitt Bf-109 employed rocket-assisted takeoff bottles during certain operations. This conventional piston engine fighter sometimes required additional thrust for heavily loaded takeoffs. Walter rocket bottles attached beneath the fuselage provided brief additional acceleration. The system allowed operations from short or damaged airfields with full fuel and ammunition. German forces employed these modifications extensively during the war's final years. Deteriorating airfield conditions and Allied bombing made conventional takeoffs increasingly difficult. Operational use proved straightforward with bottles jettisoned after burnout. The system added minimal complexity to standard Bf-109 operations. Pilots appreciated the additional thrust when operating from marginal airfields. The rocket assistance extended the fighter's operational flexibility during difficult circumstances. German industry produced thousands of rocket bottles for distribution to fighter units. The modification represented practical solution to infrastructure degradation rather than performance enhancement. Standard operations continued without rocket assistance when conditions permitted.
The Focke-Wulf FW-190 similarly employed rocket-assisted takeoff systems. This radial-engine fighter benefited from additional thrust during heavyweight takeoffs. The system matched that used on Bf-109s with similar operational procedures. German forces applied the modification wherever short runways or heavy loads demanded. The FW-190's already excellent performance gained a temporary boost during takeoff phase. Pilots employed rocket assistance routinely during the war's final year. Allied bombing of German airfields made such systems increasingly necessary for continued operations. The Junkers Ju-88 bomber occasionally employed rocket-assisted takeoff for heavily loaded missions. This versatile twin-engine aircraft served bomber, night fighter, and reconnaissance roles. Heavy weapon or fuel loads sometimes exceeded normal takeoff performance. Rocket bottles provided additional thrust, allowing departure from restricted airfields. German bomber units employed the system when circumstances demanded. The modification extended operational capability under difficult conditions. Ju-88 operations primarily relied on standard piston engines, with rockets providing supplementary capability. Allied jet-assisted takeoff development. The United States developed jet-assisted takeoff systems during the war's final years. American engineers experimented with solid-fuel rockets attached to various aircraft types. The technology aimed to reduce takeoff distances for carrier operations and short runways. Navy aircraft particularly benefited from reduced takeoff rolls on carrier decks. Development programs tested systems on fighters, torpedo bombers, and patrol aircraft. The technology remained largely experimental during wartime, with limited operational deployment. The Grumman TBF Avenger torpedo bomber received experimental jet-assisted takeoff equipment. This carrier-based aircraft carried heavy torpedo or bomb loads, reducing takeoff performance. Rocket bottles provided additional thrust during carrier launches with maximum loads. Navy trials demonstrated feasibility, though operational deployment remained limited. The system promised to increase carrier aircraft payload capacity significantly. Development continued into the post-war period with widespread adoption on carrier aircraft. The Consolidated PBY Catalina flying boat tested jet-assisted takeoff systems. This maritime patrol aircraft's heavy weight and water resistance made takeoffs lengthy. Rocket bottles reduced takeoff runs, allowing operations from restricted water areas. The system proved particularly valuable when operating at maximum weight. Limited operational deployment occurred during the war's final months. Post-war maritime patrol aircraft adopted the technology more extensively. The Catalina trials established feasibility for larger aircraft applications.
British forces experimented with rocket-assisted takeoff systems during the war's later years. Short Sunderland flying boats tested supplementary rockets for heavily loaded takeoffs. The large patrol aircraft benefited from reduced water runs during maximum weight departures. British development lagged behind German programs but achieved similar goals. Limited operational deployment occurred before war's end. The technology demonstrated value for various aircraft types and missions. Post-war adoption became widespread across military aviation. Soviet rocket-assisted projects. Soviet forces developed rocket-assisted takeoff systems independently during the war. The Lavochkin LA-5 fighter tested supplementary rockets for improved takeoff performance. Soviet engineers experimented with various rocket configurations and propellants. Development occurred alongside conventional piston engine improvements. The systems remained largely experimental with minimal operational deployment. Soviet aviation focused primarily on conventional propulsion improvement rather than supplementary rockets. The Petlyakov P-2 bomber received experimental rocket-assisted takeoff equipment. This twin-engine tactical bomber sometimes operated from forward airfields with short runways. Rocket bottles theoretically enabled operations from restricted locations. Development programs tested feasibility without achieving widespread deployment. Soviet industry prioritized conventional aircraft production over experimental auxiliary systems. The technology demonstrated promise, but resource limitations prevented extensive implementation during wartime. Soviet engineers examined captured German rocket systems with considerable interest. Walter rocket motors and jet-assisted takeoff bottles underwent detailed analysis. Soviet programs benefited from German technical advances captured during territorial advances. Post-war Soviet development incorporated lessons from German rocket technology. Wartime Soviet programs remained limited compared to post-war applications. The knowledge gained influenced Cold War aviation development significantly. Soviet rocket-assisted systems evolved from wartime foundations into extensive post-war programs. Italian experimental programs. Italy developed limited rocket-assisted systems before its 1943 surrender. The Reggiane Re-2005 fighter tested experimental rocket bottles during development. Italian engineers explored performance enhancements through supplementary propulsion. Resource limitations and military defeats prevented significant progress. Most experimental programs ended with Italy's armistice and German occupation. The technology demonstrated potential, but circumstances prevented operational implementation. Italian technical documents captured by German forces influenced later development. German engineers examined Italian approaches to rocket assistance. Some concepts were incorporated into German programs. Italy's brief experimentation contributed marginally to overall rocket-assisted takeoff development. The nation's limited industrial capacity and early defeat prevented meaningful advancement. Italian programs represented minor footnotes in jet-assisted aviation's wartime history. Transition Technology Assessment. Jet-assisted takeoff systems represented transitional technology bridging piston and jet eras. The modifications provided temporary performance improvements for conventional aircraft. Operational deployment remained limited during wartime due to developmental challenges and resource constraints. German forces employed the technology most extensively, driven by desperate circumstances. Allied development proceeded more deliberately with post-war applications in mind. The systems demonstrated feasibility while revealing practical limitations requiring further refinement. Pure jet propulsion ultimately superseded hybrid approaches, combining piston engines and rockets. The Me-262 and other jet aircraft demonstrated superior performance without auxiliary rockets. Jet-assisted takeoff remained valuable for specific applications rather than general use. Post-war aviation adopted the technology for carrier operations and heavy transports. Wartime development established foundations for widespread post-war implementation. The hybrid systems served their transitional purpose before pure jets dominated military aviation. Jet-assisted aircraft represented aviation technology's transitional phase during the war's final years. These hybrid systems provided temporary performance improvements while pure jet propulsion matured. German rocket fighters demonstrated the approach's potential and limitations simultaneously. Allied development proceeded more deliberately toward post-war applications. The technology bridged piston and jet eras, establishing foundations for widespread post-war adoption across military aviation.